we start our today's session actually. So what are the softwares we need to learn? Okay, let me open my here. Let me show you in a practical way also how this software will work. So first of all, I need to give you the brief introduction about the software. So come to the industry. So once you come out of the college, okay, so main things what you need to do, you need to join as a site engineer or design engineer. So apart from the site engineer, if you wanted to come to the office, so I think you know that how the site will look like. So you need to spend for 12 hours of time in the site in the presence of sun. So too much irritation and a lot of politics will happen there. So a lot of things will be happen. But if you bored of that, so then you need to come to the design. So come to the design. What is the consultancy work procedure? So the first consultancy, even if any client will come, they will ask you the architectural work. So architectural drawings. If you wanted to do the architectural drawings, what are the softwares you need to learn? So here is the first software, first and important software. It's not that much costly software. It's AutoCAD. I hope you guys all know that AutoCAD and 𝗕𝗏𝗃𝗃 also we have. So 𝗕𝗏𝗃𝗃 is also one of the software. So AutoCAD is mainly for the 2D drawing preparation, plans and drawings. So come to the AutoCAD. So you no one in the industry. So while you are studying learning the AutoCAD, you will ask me, so can I learn the 3D in AutoCAD? No need to learn the 3D in AutoCAD. We have a separate software for that. Okay, so just to focus on AutoCAD 2D works also. So how we can draw the 2D drawings in AutoCAD. After that, Revit. Revit also we have a 3 things. Okay, Revit is a helping software for the BIM. BIM is a building information modeling. That is one technology and it's a process of a model. Okay, BIM is a process, but this is a Revit is a tool to help you for the process. So Revit architectural we have, structural we have, MEP. MEP in the sense mechanical, electrical, plumbing. So in the Revit you can see the 3D model, interior designs and drawing preparation also. So it will also give you the BOQ, bill of materials. These all things Revit can do. Okay, so no need to focus on AutoCAD 3D. You just focus on Revit 3D. So Revit is a completely 3D. It will also give you the 2D model. So then why can't we go for the AutoCAD 3D? Okay, industry will never ask you, you know the AutoCAD 3D. They only ask you the 2D. That's it. So you can learn the 2D from the AutoCAD and you can learn the 3D from the Revit. Then only you can feel it as so you have a 2 set of softwares and also 3ds Max. 3ds Max it's a somewhat highly rendering software, and here in this elevations it will do, interior designs it will do, and SketchUp. So SketchUp is a easy software. It's not that much means a proficiency we will get. So Revit is an excellent software for the BIM and some 3D works. SketchUp is also easy software. You can easily learn the SketchUp, and it will also do the 3D modeling and elevation interior designs. And come to the structural works. So once you done the architectural works, you need to do the structural works. So how can you do the structural work? What are the softwares you need to learn? Come to here. Here is the Etabs. Etabs is a software, first software, structural analysis and design. So while we are going for the RCC structure, as of my knowledge, I already worked as a steel structure and RCC structures. So that's why I am telling you Etabs. So in the industry, the RCC designs, we will use a Etabs. But come to the Staad Pro, whenever if you want to design the steel structures, the industry will follow the Staad Pro. Okay, so even though we can do it, even though steel structure we can do in Etabs and RCC structure we can do in a Staad Pro, but mainly some of the softwares industry will follow that. Okay, come to the Staad Pro and SAP 2000 also we have. So this is a CSI Computers and Structure Incorporation Limited. So structural analysis and design. So structural analysis and design for the steel structures. Okay, come to the SAFE and Staad Foundation. These Etabs and Staad Pro and SAFE will only design a superstructure. Superstructure in the sense above the ground only. Above the ground means columns and beams and slabs and also shear walls, these things. But come to the SAFE software, SAFE and Staad Foundation Advanced. So you can design the below the ground. Okay, like foundations, pile foundation, raft foundation, come to different types, shallow foundation and deep foundation, pile foundation, and also isolated footing, combined footing, raft footing. These all things we can do in a SAFE and Staad Foundation Advanced. Come to the Csa Bridge. If you suppose you wanted to design a bridge, you need to go for the Csa Bridge. So why? Because you can do in a Etabs, but it will never give you the proper results. So if you have a particular software, is a particular that work only. At the time you need to take that software to design a bridge. So CSI Bridge is for the software. And once you've done the structural analysis, structural work, so you need to deal with the detailing work. Why we are doing the detailing work? If suppose you wanted to give any drawings to the site engineers, so we need to draw it. Who draw it? Also, civil engineers only will draw. So which softwares will help you to do that? So AutoCAD, it's again thing. AutoCAD will be the 2D drawings, and it will prepare the steel and RCC detailing also, and CSI detailing also we have. CSI detailing software will give you the 2D drawings preparation. So it will give you once you take the Etabs model, you can import it to the CSI detailing. You will get all the drawings. Okay, and it's one another software is RCDC. RCDC is a 2D drawing, BOQ, BBS preparation. BBS in the sense bar bending schedule. So RCDC will design all these, and it will give you all the drawings and bill of quantities. And come to the 𝗥𝗏, 3D steel. Okay, the 𝗥𝗏 is only for the steel models. Okay, so steel structures, 3D steel model preparation of BOM in the sense bill of materials, erection drawings it will give you, and fabrication drawings also it will give you. And here we have a BOCAD. BOCAD is when we will go for the BOCAD, if you have a complex structure in the steel structure, you need to go for the BOCAD. Okay, so these are the set of software in the industry will follow. So try to learn the software apart from the software knowledge. Okay, so practical knowledge is also very important. So apart from the software knowledge, if you have only the software knowledge, that will never help you. If you have both software knowledge and practical knowledge, then definitely you are in the next level. So before that, let me open. So right now in this session, we are going to discuss about the AutoCAD and Etabs, okay, and the Staad Pro and Revit. Okay, these are all the softwares I will show you how we can do it. Okay, so guys, see this. First of all, I hope, can you see my AutoCAD screen? Yeah, thank you. So here is let's see this. While we are in some ancient days, nearly 50 years back. So how can you draw these plans and everything? Can anyone tell me how can we draw these plans and anything? By hand or paper or pen or anything? How? By paper, right? By taking a paper and scale and these things. Okay. So if you draw on paper, so at the time it will be look like this, right? It will be look like this. We can make it as some how much is the building dimensions. Then after that, I draw on paper. Okay, so for the client representation, I don't have any AutoCAD at the time. So when I was in somewhere in occasion, so at the time I don't have AutoCAD. How can you draw this? So at least I have a knowledge. How can I decide these rooms and everything? Master bedroom where I need to place, and toilets and where I need to place. So I know that knowledge. Okay, some of the technical knowledge. Once you know the technical knowledge, either you can draw on paper or either you can draw on AutoCAD. So main thing is the technical knowledge. Okay, so if you know the technical knowledge, however you want, you can give it to the client. At the time, I don't have any software with me. At the time, I just draw on paper and I give it to the site. Okay, that client. So he felt what you felt it. Okay, if you see on the paper with some this what is the not accurate measurements, how can you feel it? So there is no accuracy and anything. So there is no proper annotation and everything. So how the client will feel? So he feels something. He is paying me. Okay, he's nearly giving a 5,000 or 6,000 for me. So if I just draw on paper, so it will look like this. So any client will impress by using this, by giving this plan. Is that a client will impress? No, not at all. So he are paying me. So I need to give at least some. So all our people, how we look like, we always attract to some attractiveness, right? So that attract will give us some better works. So this is my drawing on paper drawing. So just imagine. So but come to here, when I was in AutoCAD, I just draw like this. Okay, here I make a 20 feet wide road, and here is a 20 feet and 30 feet. Even though if you try to measure it, you can accurately, you will get how much is the length it is. Okay, if you go to here and just take how much, 30 feet. Okay, you can see it. You can see, yeah, accurately. It's a 30 feet. So this is when I was, I have my AutoCAD. So this is the east facing building and 3 BHK. So I draw like this. If I give it like this, how the client will feel? Can anyone tell me how the client will give if you give these two things? If you are suppose if you are a client, how can you feel this with on paper drawing and with AutoCAD drawing? Which one is better? Option 1 is on paper drawing, option 2. They will get impressed, right? So which so if he is impressing, so he will try to give you the next work to you, right? If he is not getting impressed, how can he give you the next work? Am I right? So that's why so as of my knowledge, what I am telling you here, so the software AutoCAD is just like a pen and paper. Instead of using the pen and paper, I will use AutoCAD. That's it. It's a tool. It's just a tool. So if you wanted to write anything line, okay, suppose I just go to the line, and every time whenever you are using the AutoCAD, so try to follow the command lines. I hope so some of fourth year and third year students we have in this session. So I hope you guys know how the AutoCAD and some works you already done. So every time you need to follow the command line. So it is asking me when I choose a line, it is asking me to specify the first point. Yes, I choose a first point here. It will ask me to specify the next point. Otherwise, I can give you some dimensions, 30 feet. Okay, then okay. So it's drawn the 30 feet line exactly. And after that, in y direction, I need to draw 50 feet. So I just type enter, it will draw it. Okay. So again, I just 30 feet. And after that, I just join these two things. Right? It's like this. Without any paper and pen, so I draw in AutoCAD with the accurate measurements, and also it looks quite good also, right? So everything, whatever the annotation I made, all these are quite good, and whatever the colors, if you want to change the colors, you can directly change it. And if you write anything on paper, so if you wanted to change any color, you need to redraw everything. So I hope you understand this. When we will use the AutoCAD, instead of using the pen and paper, we will use the AutoCAD. That's it. Okay. So, but how we can get the technical knowledge? It's a software knowledge. So AutoCAD, if you know the AutoCAD, that is the software knowledge. How we can get the technical knowledge? What is the technical knowledge? If suppose any one of the client, okay, suppose your uncle or anyone. So if you tell to your uncle, I'm a civil engineer, so he can try to give you one plan. Okay, he just simply say 50 feet and 30 feet my plan, just to draw one home, right? 2 BHK. So at the time, what do you think? So in our college, no one teach me this, right? No one teach me. How can you able to draw that? So you are not able to say to your uncle, so uncle, in my college, no one can teach me, I can't write. Okay, if you say like that, how he felt it? So he felt, why you are studying a civil engineer, maths is better than civil engineer. Like that he say. So, but they don't know how much struggle we made in our college and how to get the good marks in our college. They don't know, but they only see you this instant. Okay, this is the main first step where we civil engineers will stuck. So everyone will ask you as a plan, but you are not able to give that plan. You failed as a civil engineer at that time only. So even though after some time, if you want to try to prove it, no one can listen your words. So main thing is the technical knowledge. So if suppose your uncle give me the 50 into 30 plan, so how can you able to draw it? So I just remove the setbacks here. So based upon the some GOs, so Telangana, Hyderabad also we have some local authority, municipal corporation. So we have some GO number in Andhra Pradesh. We have a GO number 119. So there you will get how much is a setback I need to leave in front of the home, this room. Okay, in front of the house, how much is the setbacks, and side, how much is the setbacks? Even though while we are in a BTech second year or third year, BPD, so building planning and drawing, there also we studied all these, but we don't know about, and we don't know the application. So if you know the application, you can directly go to the BPD subject and you can apply here. So that is application. So once come to here, so the client will ask me the east facing building with the 3 BHK. How can I able to decide the 3 BHK? So they ask me the parking. So they need to place a car here and the 2 bikes here. And after that staircase, I need to place it. As per Vastu, where I need to provide a staircases. Can anyone tell me, as per Vastu, where I need to provide a staircases? And a kitchen and a living room and a master bedroom, guest bedroom and master bedroom, where I need to provide a master bedroom. This is a east facing plan. Yeah, can anyone tell me where I need to provide a staircases? South? What? Okay, if suppose I don't have availability on southeast, what should I do? If I don't have any availability on southeast, what should I do? Where I need to keep second option? Northwest. Northwest is the second option for the. Always we need to prefer the southwest is the first option. And if suppose if anything not sufficient for me, so I need to go for the second option. Everywhere, why in Vastu also we have some second options. So I need to place in a northwest. Wherever I got a children bedroom, I need to place here. So the toilets, okay, how can you decide the toilets? Where we need to place it? So in which direction you need to sleep? While you are sleeping, so you may get some bad dreams. At the time, in which direction you need to place your head towards what? Can anyone tell me in which direction you need to place your head? If suppose you have a means higher people and in the older people in our home, so they need to place your head towards the south. They need to place head towards the south. If you place a north direction, though maybe it will, as per Vastu, I am telling you. So if you place in a north direction, you will get some bad dreams or some disturbed disturbed sleep you may get. So that's why this is not invented by me. So Vastu says that. Okay. So there is some little science also there. So if you wanted to study the science in that Vastu, you need to go for the research. So I hope it's clear. And if suppose you have children in your home, so they need to place your head towards the east direction. Okay. I hope these are some of the rules, basic rules. But while we are in BTech, we don't focus on these things. Only we are focusing on how we get 80% marks, 90% marks, how to get a pass. That is. So yeah, we will do the some battle in that BTech. Once you come out of that BTech, so we need to get a job. How can you get it? If you don't have a proper skills, only you have a certificate, how can you get the job? So this is what actual technical knowledge you need to inbuilt in yourself. So here is the sizes. How many? Where I need to provide a master bedroom. This is master bedroom, not a main door. So this is my main door. Puja. Where I need to provide a puja. So puja I need to place in a northeast corner. Okay. So here we have a Agneyam, Nairuti. How can you decide Agneyam? Where is Agneyam and where is Nairuti? Come to some of these things and let me tell you where I need to provide. So we have a word called Anavai. So everyone will say Anavaiti like that. So if you come to here, so we need to decide Agneyam here. Okay. Agneyam, Nairuti, Anavai, Vaignam, Isanyam. Okay. So this is a corners. So how can you know this and where? So every time you are deciding this in Isanyam, we don't need to place a heavy furniture or anything. Okay. So at the time you can go for the digging the boreholes. So if you dig the boreholes, you can dig the some soil. At the time it will go for the excavation. So you can't placing any higher load. You can remove it some soil from out of that. So this is a main some of the Vastu, basic Vastu. So if you know this and you can be able to do some of the work and come to here east facing building 2 BHK. So some of a client will ask me to give me the 2 BHK with gardening and all the I need a gardening and I need a open place for the car parking, these things. Okay, at the time we will decide. So this is a ground floor and here is the main gate and these are all the garden. So you can place all the flowers and everything. And here is a car parking. And once you came here and you can you just park your car here and you can go around here main door. Again, once you go to the main door, here is a hall, and here we have a this what is this TV. Okay, this is a partition, and once you come to here puja, so kitchen and the dining hall, and here is a master bedroom, and here is a toilets. One the client asked me to give me the 2 attached toilets. Okay, so for that I need a I gave the 2 children bedroom is also attached toilet and master bedroom also attached toilets. But sometimes as an engineer we need to give some suggestions to them. But if they need particularly, we need to give as per the client only. Okay, if suppose client will not ask me the attached toilet for the children bedroom, I need to remove this door here. I need to place exactly here. So the purely depend upon the client requirements. And here southeast, and I make it as a southeast is a kitchen. Okay, this is a staircases. Once you come to the staircases, this is a single story building. So that's why we didn't draw any second floor. And come to the next one, build east facing with a 2 BHK. So this is these dimensions will be 24 into 50 feet flat, 24 feet into 50 feet flat. So after deducting these front and setbacks, so throughout the corner setbacks in all the directions, so you will get a plinth beam. So plinth beam is a 20 into 30 feet, 20 feet into 36, and after that here is a design as usual, and here is a west facing building. So every time, even though if you are going to buy any house, you mostly choose a east facing house. Okay, every time, sometimes we will get a most of the east facing houses. At the time we can modify it and we can give it to the client. Okay, so client also, we did never ask you something new. So they always ask you the as per vastu. If you go as per vastu, we can't give you any new like invented drawings. So at the time we need to give it as a so we just some modified something and we give it them. And west facing drawing, and west facing, if you come to the west facing, here is the living room. Okay, and once you come out from the main gate, you will get a main door and the living room. Once you come to the main door, if it is a hall, it is a good. Okay, so that's why you place it. And after the dining room, kitchen, and a children bedroom. And here the client asked me, I don't need a children bedroom attached toilets. That's why I make it as a common toilet for all. Okay, so and after master bedroom, here is a parking, single parking, and here is a staircases. Here in this northwest, it's not possible for me. So northwest, I have a master bedroom, main door. So that's why I place in a southeast. Okay, so like that. And here is a south facing building. If it is a south facing building, how can you design it? So this is a south, and so once you come to here, southeast. Okay, southeast. Yeah, see guys, if you come to the living room, so living room is a master bedroom and the client. So actually one thing you can observe here, sir, you said northwest is a building, southeast is for the staircases, and northwest. Why you kept a southwest staircase? But the client will ask me. So I already suggest to the client, sir, we are getting the staircases. If we place a staircases here, so just remove the toilet and everything. So we need to provide here. But I said to the client, so I can place a staircases here. At the time he said, if I just place my staircase in the back side, so I didn't get some elevation. At the time you just place in southwest. I said, sir, southwest is not good for the as per vastu. At the time, okay, no need. You can as per my suggestions, you can do it. So then no need to worry. So at the time, why I am doing this? Okay, so I need to, if the client will ask me, I need to as per client only. Okay, so here is a sit out and a living room and master bedroom and children bedroom. See here, if you go for the southeast kitchen, I need to place, right? So here exactly southeast, I get a living room. At the time, what I need to go? I need to go for the northwest. So that's why I place a kitchen exactly in the northwest. Okay, puja northeast, I may place it. Okay, puja. So always as per vastu says, no need to place a puja for the single room. Just go for the cupboards type. So that's depend upon their requirement. And here is a borehole for there, and here is a one grill. So no one can enter into the without a permission. No one can enter into inside. So if you need, here is a toilet, some big toilet for the some outside people will use this toilet. And here we have a toilet. Okay, attached toilet for the master bedroom. Okay, this is the scheduling of beams. This all. So the 20 feet wide road we have. And come to here, this is one of the shopping complex. And once you come to the shopping complex, this is so every time when you go for the shopping complex, so you need to take a maximum input from the client. Okay, if the client will give you the input, what are the input they will give you, which direction it is. Okay, so and in which how many complex, how many shops I need to make, and these things we need to decide. Okay, so here is a mid landing and this is the shops. He said nearly I need some 10 shops or anything. So 10 shops, that's why we make it as a 8 shops is a little smaller, and 2 shops will be somewhat bigger. So after that, this is the first ground floor, and here is the first floor. So the same thing will be come to the here, and this is a walkway. So if you can come in this direction also. Here is a staircases for the top floor, and again come to here, and the client asked me, I need an office room in the top of the complex. I need an office room. That's why whenever he come to here in this mid landing. So in the staircases, you just go to the waiting hall. If anyone want to meet the officer, you need to wait in the waiting hall, and once he will approve, you need to go for the here. Okay, even though you can place a door here also, that's quite good for if you make a door exactly here. So this will be quite good. If the means a PA will wait here. So if you get a allow, they will get here. But a client will ask me, no, here you can place a door here only. So I suggest to the client to just place a door here for our convenience. So client will say no, okay, I need a door exactly in this direct here only. So that's why after that he asked me some dinings or anything. So exactly here. So this is mid landing. Okay, this is what actual we are doing in our offices. Okay, so and come to here, one of the G+6 story building. So this is a AutoCAD. Okay, so whatever the knowledge will help you to draw this building, that is a technical knowledge, and the software knowledge will help you to draw this plan. So this so whatever you draw in a paper, you need to draw in AutoCAD, so giving you some better visualization. At the time you need to go for the AutoCAD and you need to draw it. But if you wanted to draw on paper, how can you get it? So you need some technical knowledge. So where I need to provide the doors, and which code book, which books, geo books I need to study, which where I get the Vastu Shastra, and these all things you need to know. That is a technical knowledge. Software knowledge is somewhat that's another concept. Okay, come to here. Once this is, I hope you understand how we can use the software. And come to here, this is a G+16 story apartment building. It's a 3 BHK. Just see apartment building, and here we have a staircases and a lift also we have here. And once you come to the main door, and this is a living room and dining room and a kitchen and a utility, toilet and bedroom and toilet, and here is a bedroom and toilet also. So 3 BHK, three bedrooms with the attached toilets. See guys, the client asked us to give you the attached toilet, but these of the work will mainly done by the architects. Okay, architects also comes from the civil engineering, and they also come from the architect background also. So if you are familiar with some of the softwares and some of the technical knowledge, you may also work as an architect in our from the civil engineering also. Okay, and here is a puja, and here is some 7-feet balcony, wide balcony and bedroom, and here is a 30 feet wide road. Okay, so once you done this, when we will go for the ETABS. Okay, this is architectural work. So if you go to the structural work, you need to decide the column placing. So column placing and column orientation is a main important thing. Okay, so where I need to provide a column. So why can't I provide a column here? Why can't I provide a column in this here? So these are some of the rules we have. So once you decide the column orientation, which part, okay, who can do this column orientation? Structural engineer will do the column orientation and these things. Structural engineer. Okay, this whatever the architectural plan will draw, that architect will do. And once you come to the structural engineer, architect also will give you the initial column placings. But we structural engineer will revise those column placings by discussing the architect. Okay, once you done this, so we need to decide the column placing and center line. Guys, see this. This is the center line for the columns. All the columns I took from here, and I make a column layout here. So so these are the grids, and here is a grids in A, B, C, D. So like that, and here is a beam layout. Once you done the column layout, we need to do the beam layout. Once beam layout was done, so here is the slab layout. So which slab? So we already studied Ly by Lx is less than 1, less than 2. We will get this Ly by Lx is equal to greater than 2. So it is a one-way slab, and Ly by Lx is less than 2. Less than 2. We need to decide as a two-way slab. Okay. So based upon that only. So whatever we studied, that is not wasteless. So those things we need to use in the industry. So that while we are in BTech, we only study for the marks, but study for the knowledge. Then only you can get the good jobs. And this is a slab, and based upon these Ly and Lx, I make it as a two-way slab. And here I got a one-way slab. This is a toilet portion. Toilet portion also we can see the sunken slabs. So sunken slabs we have. So that is the sunken slabs is some different. So while we are placing the toilet, we need to provide some sand, and the toilet instruments also. That what is that? Those pipings and everything need to go in some deeper inside of that slab. So that's why we go for the sunken slabs. That is somewhat another concept. So come to here, when we will go for the ETABS. Okay, so ETABS or either Staad Pro. So when will we go? So based upon this column layout, I need to take these column layouts. I need to go for the ETABS. Let me show you before that. Let me show you one thing. So this is a pre-engineering building. So pre-engineering building, PEB. So I hope you didn't hear this name, pre-engineering building. So if anyone hear that name, so I'm very happy. So pre-engineering building is a steel structure. So whenever if you are placing some materials, some rice or any material like godoms type, it's like a shed type. So at the time you need to go for a steel structure. This is an anchor bolt plan, and here is a canopy, and here is a bay, how many bays, even though in this steel structure also, the client mainly give you the length and depth, breadth. So length and the breadth of the building. So after that, based upon that length and breadth, as a structural engineer, we need to decide how many basings we will get. How many bays? Yeah, 7.5 I decided, we decided, and 7.5, 7.5, 7.2 total, you will get a 30 meters, okay, outer to outer of the steel line. Okay, this is I hope so you can see here, this is here we will get like this. Okay, even suppose why we are going for the steel structure instead of RCC, so that is also you need to learn. Okay, these are the gable columns. Okay, here whatever we have, these two are the gable columns. Whenever the wind force is acting on this steel structure, so these gable columns will resist that. Here is the roof sheeting. So sheeting we can provide, and here is the sheeting, and whatever the X-shape bracings we have, that is bracings which will transfer the tension. So while we were in BTech, we studied the transfer the tension to the column footing. So we need to provide a bracings. Okay, so those are the bracings and roof bracing and eave gutter. Eave gutter in the sense whatever the rainwater will come. So see, let me draw it for our better understanding. If suppose this is your pre-EB structure, okay, so you have a columns like this. So whatever the rain will fall on this this roof, it will be carried to this one. Okay, like this it will happen. So if you place a eave gutter here, exactly. So if you place a eave gutter like this, so whatever the rain will come, that will collect here, and we will place a down spots. This we call it as a down spots. Okay, down spots. So based upon these, through these down parts, all the rain will be come to the ground level. So that's why if you leave it as it is, it will leads you to all the rain, that water will go. So if you have any rain harvesting pits, you can directly connect with the down spots into the rain harvesting pit. Then it will be work out. Okay. So under this is a side seating. So how much is a rolling shutter? Okay, you can see here. So every time this is a canopy. So it's like some shed type in the so whatever the rolling shutter it is, so you can lift it, and here is a wall brickwork. Okay, so nearly 3 meters of height we will use the brickwork. Everything, even the steel structure or everything, we can draw in a AutoCAD only. So some of these softwares we have, but AutoCAD is a better and excellent tool for the 2D drawing preparation. That's why we will go for the AutoCAD. So I hope you can see here, this is architectural work. So I said this is architectural. What is the structural work? So let me go to the Etabs. So let me show you. This is a project G plus 15 stories project. Based upon these feet and inches, so column spacing, I need to go for the Etabs. Okay. So let me open Etabs. How we can assign the loads? So come to the Etabs. AutoCAD will never learn by 10th class or intermediate students. Or if anyone will spend a nearly 30 days or 60 days, so they can excel in that AutoCAD. But come to the Etabs, no one can learn it. Okay, so only the structural engineers, okay, whoever studies as a civil engineers, they only will learn this. Why? Because it's a software knowledge is somewhat lesser, and the technical knowledge is more than. Okay, so this is a building. So if you want to see, let me show you that plan view. Just go to the plan view and the footing ground level, and it's in the plinth level. So here whatever, see, you can see all the see whatever we seen in here. Just see it. Okay, this is a column placing, and I make it as a here only. I hope you can see it, how we can use it. Based upon these column A, B, C, D grid and 1, 2, 7. So these grids I make here, and after that we will design this by applying some loads and these all things. How we can apply it? So what are the loads I applied here? So let me show you what are the loads. If you come to the frame loads, so just go to the display frame assign loads. Just go to HDL load and click on apply. Once you click on apply, whatever the loads I applied on here in this building, so that is the brickwork load. Okay, so if you see exactly here, so yeah, go to the architecture plan. So in this below level, you have a brickwork. Okay, so whatever the brickwork we have, so that entire brickwork will be acting on this beam only. So this beam. Okay, so that's why we applied some brickwork load here. Okay, so see this, click on apply, click on OK. So if you just go to the frames and click on HDL, click on OK. So how much? I think we didn't apply the ground load. Yeah, you can see it. Okay, here is a 7.1. How can you calculate the 7.1 load exactly? So how we can calculate it? Let me tell you. So if you just go to the brickwork, how much is the brick wall height? Height of the brick wall is nearly 3 meters, right? 3 meters. Okay. So 300 mm. How much is the thickness? So thickness we will go for the 100 mm. Just imagine 100 mm. So unit weight of the brickwork. How much is unit weight? Thickness into and the height into unit weight. Then thickness is a 0.1. Okay, so 100 mm into height 3000 and into 18. Okay, if it is a red clay bricks, red bricks, we need to take 18. But if it is a AAC bricks, auto aerated clay, so we need to take a 8 kilonewton per meter square. Okay, it's a meter. So based upon this calculation, I apply the load here. Okay, so this is what we need to calculate it. Once you apply that, just go to the slab loads. Once you click on here in the slab loads, just go to the slab loads, and here is the live load. Let's choose live load. So you can see why I am applying some 3 kilonewtons here in the corridor, and in the balcony I applied 2 kilonewtons. In the staircase here I applied 3 kilonewtons. Why I applied? Which code book it will tell you. So let me tell you the code books actually. IS 456 for the RCC, you know that. IS 800 for the steel structures, you know that. IS SP 16 for the design aids, you know that. IS 875 part 1. Just try to note down if anyone wanted to just dead load. Okay, part 2 for the live load. Okay, live load. So this is a live load. So based upon this code book, IS 875 part 2 code book, I took this 2 kilonewtons. Why I took this 2 kilonewtons instead of 3? If you go to the that code book, you will get it. Okay, so part 3 for the wind load. If the wind is acting on our building, how will get it? How much load will acting? Part 4 will be for which one? So snow load. If you go for the America, US are there. So mainly so snowfall will be happen. How it will be rain falling here in our India. So snow falling will be happen here. At that time we need to design our building with the snow also. So part 5 for the load combinations and special loads, some blast loads and like that. So these are the, and come to the IS 1893 for the earthquake. Okay, and IS 16700. Whenever if you go for the 50 meters of height, above 50 meters, you need to go for the tall structure building code book. This is a tall structure building code book. And come to IS we have IS 13920. So ductile detailing and SP 34. This is a general detailing. So these are the code book. Okay, so apart from the 3 code books, how many code books we have? So if you learn these all things, you may able to work as a structural design engineer. Okay, you may able to work as an architectural structural person, draftsman or like that. Okay, so this is, and if you go to the earthquake load, how I can apply the earthquake loads in this building? Just go to load patterns. Yeah, once you go to earthquake X, it may be acted on X direction also, Y direction also. So what are the parameters I gave? So here is a zone factor is a 1. Why I give a zone factor? This building is in Vizag. Vizag will be come from the zone 2. So that's why I need to give it as a 2. And soil type, my soil is a medium type. So that's why. And time factor, how we can calculate it? So for the calculation of the time period, so we have a formula in IS 13920. That formula is equal to T is equal to 0.07 into H by root D. Okay, 9. Okay, 0.09 into H by root D. Based upon this formula, you will get this time period. So H is the height of the building. So if you have a 43 meters of height, so you need to take from that. And here is the depth. Depth means the sense width of your building. So suppose it is acting on a EQX direction, EQX. So in X direction, how much is the width we have? That building. Okay, that is the main thing. And after that, response reduction factor. When we will go for the response reduction, these all things we need to know. Okay, come to the wind load. So here you can see it while I am choosing the earthquake X. Which code book I choose? IS 139 2016. Etabs having the code book. So whatever the code book you mention, that will do that. So Etabs will take care of that. But you need to judge that. Is that Etabs giving you correct or not? If you go to the wind load, so here in design speed, so we have a 50 meter per second. But if you take the IS, if you go for the IS 1893 or 875, so if you go for the IS 875, we can check how much is a Hyderabad basic wind speed. Hyderabad basic wind speed, how much? 44 kilonewton per meter per second. Sorry, meter per second, 44 meter. But if you come to the Vizag, so Vizag is a 50 meter per second. Why? Because it is in a sea area. Okay, so sea coast. That's why the wind will be going somewhat high. Okay, so and here also terrain category factor, importance factor, and so risk coefficient, topographic. how we can give it a parapet wall, and how we can define the diaphragms. These all things. Okay, so these are the important things. So if you don't know these concepts while we are in BTech, how can you get job as a design engineer? Okay, once you've done it, we will get a bending moment and shear force. Can anyone tell me what is the difference between structural analysis? Can anyone tell me the difference between analysis and design? So how we can see the bending moment diagram? So if you go to the bending moment diagram, click on here, click on OK. Give me a minute. Can anyone tell me, is there a difference between analysis and design? What we have studied in our BTech, RCC, structural analysis, SA, what we studied, and RCC, what we studied. This is the main thing, right? Yeah, someone will try to tell that. Can anyone tell me? Find the forces in the members. It is a structural analysis or okay. Good. What is the difference between design? What you call it as a design? Wow, that's good. And only dimensions or anything else? May I know these both of you guys are names? Hello, Tejashvi and okay, guys. You said correct. Whatever you said, and see, I don't criticize someone, but see here, structural analysis. While we are in a structural analysis, what we do? So just imagine, if anyone, this is the most common question we will ask you from the. So yeah, just give me a minute. So okay. So anyways, so see this. While we are doing the structural analysis, what we do here? So there we took some beam. Okay. So fixed beam. We applied some load on that, some UDL load or point load or anything. By giving conditions, we will get a bending moment and diaphragm, bending moment and shear force. That's right. We will get a bending moment and shear force. So this is an analysis by applying the loads. How much is the stresses we are getting? Okay, what are the bending moment and shear force we are getting? That is a structural analysis. What is a design? So based upon this, what we do in RCC. So in a textbook, it will give you the bending moment. So we will design a section size and AST. So based upon this bending moment, how much section I need to take? What is the formula for depth? Okay, I need to find out this depth of this beam. So how can you make the formula? D is equal to mu by some 0.13 something is there. Okay, can anyone tell me? Root over mu by d. Based upon this movement, I will find out the depth of this beam, right? So if you got the depth, so you are deciding the section size. Okay, sectional size of that. So after that, what we need to do? We need to decide the reinforcement. So how we can decide the reinforcement? We have a formula. AST is equal to 0.87 FCK BD some 0.87 something FCK by some year. Okay, mu, like that we have. So based upon this moment, we find out the AST. So we have a moment here. I will decide the depth and I will decide the reinforcement. That is what we need to do. If suppose moment will be higher, maybe my depth will be higher. If the depth will be higher, my moment is higher, my area reinforcement still also be going to higher. So this is a relation between. That's why in our curriculum also, first we will study the analysis, structure analysis 1 and 2 and 3. After that we will go for the RCC 1 and 2. So this is a common procedure. So even though in our ETABS also we will do the analysis, I apply the load 7.1. After that I got a bending moment. So see this. So bending moment also we have some different types. So if it is a fixed, we will get a bending moment, hogging and shagging. Okay, here in the top we will get a hogging, and in the, so if I just right click on here, so just select the frame and just right click on here, so you will get a see this. So here you can see the bending moment. How much bending moment you got? 55 kilonewton meter. And here is a hogging. We call it as a hogging, and here is a sagging. Okay. Whatever we do in RCC, same thing ETABS will also do. But we need to judge the software. So whatever I do in the manually, that is correct or not in Etabs. Okay, we simply rely on Etabs software, Etabs results or Staad Pro results. Softwares will give you the correct. Why? Because they will do the lot of background work. So for generating these softwares, so that's why they will inbuilt all the code books and everything. So like that. Okay, so I got a bending moment. Based upon that, I need to get a shear force. How can I get the shear force? Let me show you where we will get the shear force. Let's go to the define, and here is a shear force. Shear 2. Once you click on here, shear, right? This is a shear force. So based upon the shear force, so while we are in a BTech, what we studied, if it is a bending moment, so bending moment, we will decide the AST, area of the steel. It is the main reinforcement. If you go to the shear force, okay, shear force, what we will decide? Shear reinforcement. That is called stirrups. Okay, stirrups like this we have. Okay, give me a minute. So based upon the shear force, we will decide the stirrups. So Etabs, how the Etabs will do? So this is a shear force, right? So let me show you the bending. Wait a minute. So I think it's going to design the. So yeah, sorry guys, I need to design. Unfortunately I click on some steel deck design. So that's why I designed. So it will take a little bit time actually. So just see this how it will be designing. So Etabs will going to design our concrete design. So once it design, it will show you the bending moment and so reinforcement. How much is the reinforcement we need to provide in that beam based upon that bending moment and shear force. How much is stirrup reinforcement we need to provide. So just give me a minute. Sorry for the inconvenience. Okay, this is what actually Etabs will do. Okay, and even though we have a software, yeah, see this. So 229. What is the 229? So even if you let's explain you few things actually. So if you go to the top floor and somewhere we have a, see guys, here let me brief outlook on how we can decide. So this is a 1081, right? And here is a 61, and here is a 125. It is a mm square. Okay, and here is a 271, and here is a 111. Okay, so 189. So based upon this, I just draw bending beam depth, and I will place a first my stride bar here, exactly like this. Stride bar, top and bottom, where I got a higher reinforcement, exactly in this higher reinforcement I got. So I need to provide a extra reinforcement based upon these results. Okay, so here also center also I got, right? So if suppose if I draw bending moment for this structure, so it is a fixed beam. Okay, so it is a fixed beam. I apply the UDL load. How you will get a bending moment? So this is a bending moment, right? So how it will be related to the bending moment with the shear force? Wherever I got a higher reinforcement, exactly here, this is a negative reinforcement I got, and this is a negative, and this is a positive. Wherever I got a higher reinforcement, there I need to provide a extra reinforcement. Okay, so higher bending moment. So based upon this only, I need to provide extra reinforcement. Here I got a higher one, and here exactly I got a higher bending moment. So that's why I place extra reinforcement, that black color. And here also I got extra reinforcement. Everything that AST, area of the reinforcement, will decide on the bending moment diagram only. Bending moment diagram. So this is how we can see it. Okay. So and if you want to see the stirrup reinforcement, so just go to display design info, and once you click on a shear reinforcement for the shear force, okay, whatever the shear force we apply, it is showing you 256. Okay, 256 mm square. So you need to decide as a two-legged shear. So it's a two-legged. So based upon that two-legged, 100 we will get. So 100. So we will decide. So 8 mm dia at 150 mm center. 8 mm dia and center. Okay, like that we can do it. So I hope you understand it. This is what we are doing in a consultancy. Okay. So main thing, first of all, if you go to the Etabs, main things will be you need to learn the code book knowledge. Okay, as well as software knowledge, we need to learn the code book knowledge, some of the technical knowledge. Technical knowledge in the sense when we will go for the shear, the secondary beams, when we will go for the main beams. So these all things are the technical knowledge. Okay, why we are assigning the diaphragms? Okay, can anyone tell me why we are assigning the diaphragms? Even I think you don't know about the diaphragm. Okay, I think. Okay, mostly when I was in a BTech, I don't know the diaphragm. But once you done that, we will know that. Okay, so this is how we can do the Etabs. Okay, this is a RCC design, and let me show you the next software. So before going to the next software, let me show you. So based upon these results from the Etabs, so what I need to do, this is my results, whatever the reinforcement and all the columns and everything. So I need to give it to the site engineer for executing this building. Okay, so for that we need to go for the AutoCAD structural. Again, I need to draw in a structural AutoCAD only for the structural drawing. Okay, so let me show you that structural drawing, how we can draw it. So this is a architectural plan, and after that we will decide the columns, and based upon that we will get a footing reactions. If you go to here and just go to plan view and go to the footing, click on OK, click on apply. Okay, so just go to here, reactions, display reactions. I need to choose some reactions and tabulated form, click on apply. Once you click on here, you will get all the reactions. So this is the reactions. So how much load is coming here? So 180.44. So based upon the SBC, we will get a footing size. How much footing? How we can get it? So I think due to time being, I'm not able to explain you these in depth. So this is how we can decide the footing. Once you decide the footing sizes, you need to release the footing drawing. Okay, this is how we can decide the footing drawings. This is a column size, and this is a C3, this is a column, and F3B. F3B is the footing size. So if it's a F4B, F4A. So like that you can decide all the, it's a lift. Okay, in the lift we need to provide some raft. So that's why we make it as a raft here. So this is in a feet and inches. Okay, every mason will be familiar with the feet and inches. So if it is a government work, we need to give it as a meters. Okay, so like that we can give it all the some development lengths also we have here. Okay, tension, if it is a tension 8 mm, how much is the development length I need to take? Okay, so this is how we can draw the footings. Once you decide the footing, you need to give it as a scheduling for the column. So column, how many bars I need to provide? See here, 8 mm dia bar up to where? Okay, so you can see this is a mixed design, M20, M25 for the columns, M20 for the footing. So like that you can design it. Okay, once you done it, you need to give it as a section drawing. So this is a sectional view, this is a typical plan. So you are not able to draw all the footings. So that's why we generally give the typical plans. Okay, and here is a staircases, and this is a footing, and this is eccentricity footing. So suppose your footing is not your column will be, footing is not center of the column, so you need to go for the eccentricity footing. Okay, at this eccentricity footings, so we will get a tension, it will try to create the tension. So here is a column raft, and this and shear wall, how we can give it as a shear wall, these all things. And if you go to here, and this let me show you, this is a beam design. Okay, so based upon these results, whatever I shown you right now, how we can decide. So based upon this only we can draw it. Okay, let me show you one thing, one example, how we can design this, how it will be related to the bending moment. Okay, so see this, let me show you one thing here. Where is this column? Wherever we have a column. So guys, see this, here we have a straight and extra. So let's imagine. Okay, so this whatever I explained here, so let me explain you once again. So if you see exactly, so this is a footing, continuous. Okay, so fixed one, and I applied some load here. So how I will get a bending moment? So hogging and sagging. So based upon that only, see exactly extra rod with the pace here. Okay, see yes, to one number 16 dia extra rod. This is extra rod. That's why here we got a maximum bending moment. So that's why we provide extra. So and also straight also here, and here also provide extra one bar with the 16 dia extra bar. So based upon this bending moment, and here in the middle, in the center, we got a negative bending moment, positive bending moment. That's why I provide a extra here. See is 2 number 16 dia. So straight bars will be there. So straight bars will be there, and apart from the straight bars, we need to provide extra bar. Where we need to provide? Wherever the bending moment we got, so there we need to provide extra bar. Okay, so this is how we can design, how we can give it to the site. So so I just simply take this screenshot, this PDF. I will send it to the client site engineer. Then they will execute this building. So this is how the actual work is going on. Okay, so before going to the next software, so Staad Pro, how we can decide the Staad Pro. So Staad Pro also same, but whenever if you go for the some steel structures, we need to go for the Staad Pro. So let me show you one steel structure. So monoslope steel structure. What is the monoslope in the sense? Let me show you. Wait a minute. So can anyone try to search on Chrome? So you will get what is a monoslope? Monoslope building. So let me search on it. Give me a minute. Yeah. So if you, meanwhile, if you get any doubts, you just try to use the chat box. Then I will give you answers once the session will end. Mono slope, right? Building. So this is a building. Monoslope building. Let's see, this is a steel structure. See guys, here is a monoslope type of structures. So once you go to the images, yeah, see, see this. This is a best example which I wanted to show you. This is a steel structure. Okay, it's a monoslope structure in the sense how it will be, where you will get the proper. Yeah, see this. I hope it's clear. So this is a monoslope structure. See this, all the trusses and everything is there inside of that building. So give me a minute. Yeah, this is a type of structure what we need to design. This is monoslope building. So whatever the things you want to place in our building, so you need to provide a monoslope. Okay, let me show you in the ETAP. So always Staad will be mainly for the Staad we will use, the industry will use as steel structures. Okay, so if you go to here and the properties you need to go, just go to the properties. In these properties you can see taper steel. What is the taper steel? This is a column. Okay, these two are the columns. If you just click on edit, you will get some width and depth and everything. Okay, so I just click on, here is a flange depth. So while we are in BTech, we studied about ISMC, ISLB, these things, right? So ISMC, how it look like, this is ISMC. Okay, ISMB 300. Okay, 300 in the sense this height will be getting a 300. This is a hot rolled section, hot rolled sections. Okay, while we're in the hot rolled section, but come to the PEB is mainly for the built up sections. Okay, so but if suppose, so for my bending moment and shear force, this 300 is not enough, so I need to go for the 400. So and in the 400, so this is a PEB will look like this one only. Okay, so this, and here is the depth will be 300 and here is a 600 you will get. Okay, and even though if you see in this our in this one also you can see here. So if you see here, you can see the some lesser one section. Okay, section will be lesser here, 300, and in the top you will get a 600. It is a 600. So this is called, we call it as a pre-engineering building. Wherever the bending moment is required, there only we will provide a higher reinforcement, a higher depth of the steel structure. So that's why we call it as a pre-engineering building. As per the engineer recommendations, we will design it as a pre-engineering. So here is the depth of the section where it start end. So this is the flange width and the depth and the thickness and the web thickness, web height. These all things we will give it. Okay. Once you see the render view, just go to the view and click on render view. Once you click on the render view, see here. So this is right now we design as a not any taper section. Entire section will be throughout. Okay. So after do the analysis and design, so you will get it. Okay. If suppose this will be sufficient or not, then we will decide that okay, it's not sufficient, I need to increase the depth. So then only I can go for that. And after that, just go to the material. So once you come to the specifications, what are the specifications and support? So we give it as a pinned support here. Okay. So just click on edit. Okay. I hope it's a fixed support. Why we are giving as a fixed support? We didn't get any tapered shape. That's why we give it as a fixed support. Come to the loads. So loads in the sense earthquake we need to apply. So as per IS 1893, earthquake load we are already applied. So and earthquake in a x direction, minus x. So the plus x and minus x we applied, and the dead load. So self weight of the dead load. So dead load self weight we assigned, right? So minus 1. And here is a dead load will be minus 61. Minus in the sense in the global y direction. Okay. So if you come to the directions in the ETABs and Staad Pro, so ETABs will follow the ETABs is always so straight dimension and a globe 3D dimension is a Z. Okay, but in the Staad Pro it will be the Y. Okay, even if you want to change it, you can change it, but defaultly it will take a Y. So that's why I need to apply in the Y direction only. So that's why we give it as a global. It will be applied on the downside, right? So that's why we need to give it. And after that, a wind load. So if you click on here, wind load. So while we are applying the wind load, this is a wind load. If suppose this will be in this direction, it will create some suction. Okay. So we already studied about internal pressure and the external pressure. These all things in the different directions we provide different loads we provided here. Okay. So and in the y direction in the W2, CP plus. So this is this. These loads will be changed. Whatever the blue color we can see, those are the lines. Okay, it will be acting on the column, and it will be one is a windward force and another one is a leeward force. Okay, so like that we have, and this is a suction. It will create suction. And where we will get this? How can you calculate this? So if you go to the IS 875, if you go to the IS 875 part 3, there we have a tables. H by D is under W by D. There we will get this forces, the coefficients and everything. Okay, so part 3 for only for the wind structures, wind load buildings. Okay, so wind code books. So this is how we can see it. And after that, once you done the analysis, you need to check the bending moment and shear force. Just go to the post processing mode. Once you click on, just give me a minute. We just go to the post processing mode, and let's go to the post process. I think workflow requires a run analysis. Let me run the analysis. So once you click on the run analysis, it must be 0 errors. If you have any errors, I think you may did something wrong. So it must be a 0 errors. So it's taking time actually. Guys, give me some the next software is a Revit software. So definitely Revit is excellent software. That's my favorite software is a Revit. So 0 errors and 0 warnings. Okay, it must be a 0 errors. Otherwise you did something wrong. So once you done that, go to the post processing mode and click on OK. Once you done that, you need to go for the MZ. So how much is the moment we got? This is, and if you wanted to see the shear force, how much is shear force? What you got? Okay. So under MZ, if you go to based upon this movement only, we will decide the section size. Okay. So let me tell you one thing. So I don't want to miss the concept actually. So try to take some time actually. So if you give it as a fixed support here also I got a bending moment. If you suppose you give a bending pinned support here, so you will get a bending moment like this. Okay, this is a column. You will never get any bending moment at exactly here. So at the time you will decide your foot size will be column size. This is a 300 and this is a 600. Okay, so based upon that only we will decide it. Okay, after that we need to design this building, and we need to get a utility ratio. How much is the utility ratio we are getting? Utilization ratio. And whatever the frame sizes I gave, so those are correct or not. Just click on a design and go to steel, and you need to choose a steel IS codebook and click on run analysis. Once you click on the run analysis, it will design it and it will show you the utilization ratio. What is the utilization ratio? Can anyone tell me? So just go to the post processing mode. Once you click on the utilization ratio, you can see it. So what is the utilization ratio? If you see, the ratio will be how we will get the ratio in the sense. So you decide, you make a one column here. Okay. So this is some ISMB column. ISMB column. It has some 100 and 120 kilonewton per meter square strength. Kilonewton per meter square strength it has. But you are applying some 40 kilonewtons of load. 40 kilonewtons of load. Kilonewton per meter square load you got. So at the time what you need to do? 40 by 120. How much you will get? That is a utilization ratio. It must be less than 1, right? So whatever you are applying it, so whatever the load you are applying on it, so it will be less than that capacity of that beam, right? It must be less than the capacity of the beam. If you got if I applied a 150, so my strength of the beam will be 120, then I will get a more than 1.2 like that. So if you get a 1.2, I need to revise all the section sizes. Whatever the section sizes I initially gave, so I need to revise these all things. If it is a 1.2, so I need to revise that. After that, I need to analyze. It must be below 1. Then only it will be satisfied. Even you can imagine you have a 50 kilonewtons of carrying capacity, but someone will apply 100 kilonewtons of carrying capacity. Then you will get a more than 1. So you are not able to take that load. So you need to eat something higher, and then you need to get a 150. Then only you can sufficient to carry this load. So that is the same thing will happen in a steel structure. Okay. So whatever the beam you are designing it, suppose this utilization ratio will be more than 1, you need to increase the section sizes. and then after analysis, and it must be less than 1. So then only you can decide this is the main thing. Okay, so this is how we can. But one thing you can ask me, sir, we have some number of bays, why you are choosing the one bay? So this is the only one frame. As a structural engineer in the steel structures, every time some of the most of the times all the steel structures will take the one frame only. We will design it, we will give it to the draftsman. Okay, structural draftsman, they can design, they can model it. Okay, but they don't do the some 3D analysis in this steel structures. Okay, most of the works we see, they will structural engineer only do one frame. They took the one frame and they will design it. As per that, we will give you the all the frames. Okay, so same design we will give it to the all the frames. But suppose if you have a heavy length and a heavy mass, then only at the time you can design it 3D way. So I hope you understand how the Staad Pro will work. So based upon that results, we will decide we will design this bending moment and these all things. Okay, so after that, let me show you the Revit actually. So Revit is too much software, and let me try to open one sample model for a better understanding. So just give me a minute, I think it's opening. Yeah, come on, yeah. I hope in the meanwhile it will take some time actually. So in the meanwhile, if you have any doubts or inquiries, you just come to the chat box. Let me try to remove this AutoCAD, these things. Otherwise, system may going to hang. So no, I don't want to save it. So do you have any doubts or any queries? So anyone know the Revit? Anyone work with the Revit till now? Any of the students will use the Revit? So if you have no problem, you can turn on your mic and you can say. Anyone? No one? No. Yeah, it's opening actually. So no one. I think someone will change message. No. Yes, Karishma. So yeah, can you turn on your mic? If you don't mind. Can you tell me why we are using the Revit? Anyone tell me why we are using the Revit? What are the some of the? Yeah, can you tell me? 3D designing or modeling or drawing? Which one? Designing? Okay, so as of my, I will say 3D modeling we can do in the Revit. Is that correct? So did you made any model in that Revit previously? So what type of a building you modeled? 2 BHK flat. Okay. So how much hard it is? Is that Revit is a hard or easy, or having a lot of stuff to know? What do you find out of it? Yeah, Revit is it's not like AutoCAD software. It having a lot of stuff to learn. Okay, so even if you spend a 1 month time by enjoying this, you would never get a Revit software. Okay, completely. Revit is a vast subject. Okay, so if you want to learn it, you need to focus more on that. And we have a lot of things. Even though Revit, so some of the mechanical engineers will work, and the electrical engineers will work, and plumbing engineers will work, and structural engineers will work, and architects will work. So first, let me tell you the general process, what will happen. So as a client will ask me just do the model in Revit. So as an architect, I will do the model. And after that, I need to give that to the structural engineer. He just to do the modeling and structural engineering. He will take the Etabs, not only design in a Revit, he will take the Etabs or Staad Pro or anything. Okay. So whatever the things he wanted to familiar, he can design that in that software. After that, he will give it to the he will give it to the electrical. So electrical person will arrange all the electric equipments, and the plumbing person will arrange all the plumbing materials, and mechanical person will plan all the equipments. Okay, ACs, air ducts, and these things. Once all this done, so we need to do the class detection. So if suppose any architectural and structural member is going to collide or anything before going to construct, okay, it is a before going to construct, it will tell you is there any structural member or going to collapse, and after that we need to make a class detection with the electrical drawing. So if anything will be collided, so we need to revise that drawings in presence of this electrical engineer and mechanical engineer. So like that we need to do. So if it is a single floor building or second floor building, no one can go for the Revit. This has a lot of buildings, like in all the Dubai and somewhere in the abroad will already working on the Revit. So they having a vast experience in the Revit. Okay, so that is so whenever if you go for the high-rise buildings or nearly 40 acres of land, there we need to construct a big shopping malls. At that time only they prefer the Revit. Okay, even we have some G+10, no need to worry. Okay, they can use it, but particularly, so if suppose if you're going for the some 100 crores of project, if anything class detection will be happen on the site, so what you do? So you don't know what will be happening at that exactly at that time. Based upon these three different drawings, if you're going to construct, one duct will be going through the straight to the shear wall. How can you rectify that? How can you say this duct is not supposed to come here? So at the time you need to see the solution. So that solution must be in economical. So you no need to tell that, sir, you need to take this AAC duct into this around of the building and you go to the destination. So it will increase the cost. So that's why in the beginning of the process, beginning of the design, we will decide all these things. After that, we will go for the construction. Okay, that is what the Revit will do. So before that, let me explain you the Revit first of all. So here is the architectural. If anyone architect will work, this is a panel. Architect will work, and here is the structural work will done. So beams, and if you suppose, let me show you that plan view. So if I go to the plan view, then I'm able to, you can understand it. Guys, don't worry if it is a lag. So just give me some time. Actually, I need to explain you clearly. So it's excellent software. That's why I don't want to skip the concept. So as much as possible, I can explain you. So yeah, see this architectural and structural and steel and systems. In this architectural, so architectural person will work. Okay. So in this architectural, the architectural person will work, and in the structural engineer will work. So if suppose you wanted to place a rebar and the area, some shear reinforcement, all the connections and isolated footings, if you wanted to show all these, and you can sheet. Okay, so if you go to the steel structure, so steel, so here you can see all the steel structures, so plate, bolts and welds and these all things. And if you go to the systems we have three different categories: MEP, mechanical, electrical, plumbing. Okay, so let me show you that. So here is the HVAC, heat and ventilation, air condition, and fabrication, and PID collaboration, mechanical, plumbing, electrical model. This is the electrical engineers will work, and plumbing engineers will work, and mechanical engineers will work, and fabrication, HVAC ducts. These all the members will work on that particular project. So that's why we need to, so as a civil engineer, we need to learn the architectural and structural. So if you are very much interested, you need to go for the mechanical and electrical. Otherwise, as a civil engineer, we need to learn either architect or either structure. Which one you are interested, you need to learn that. Okay, before going to see the Revit, so this is one of the sample project. So here we can see the project browser. In this project browser, you have a plan views, floor plans, and 3D views, and elevation, section, and section walls, and detail views, rendering. Okay, so let me show you the plan views. This is a single first floor, level 1, and if you go to the level 2, this is a 2D plan. Okay, so guys, in this you can see the 2D plan. I hope this is a secondary beam, and this is a level 1. In this level 1, you can see bathroom and hall and kitchen and drawing and laundry and living and mechanical. Okay, so this is a mechanical and bath and laundry, and like that we have. Okay, so even though you can see some of the dining table here. Okay, kitchen and annotation and some grid lines. Based upon the grid lines, we will take these grid lines, we will go to the Etabs, we can design this building. Okay, and go to the level 2. Level 2 is some another floor, and just click on here. So this is only up to here. This is observation deck. So this is, here you can see the bedroom and bathroom and all the bedroom, master bedroom like this. Okay, and if you go to the 3D view, you can see the 3D view also. This is the approach you have, and how it look like. Okay, just see how the in 3D view how it look like. Then you can see here. Yeah, see this, how beautiful it is. If I just delete this this door in this 3D view also, that will be deleted in the plan view also. Everything is a parametric. Okay, so whatever you do, make changes in the 3D view. If suppose elevation you didn't find anything, you can work on a 3D view. Okay, these are the some trees and car and these all things, and some fan and wind generated fans. Okay, electrical generated wind fans, and some from ad. So from ad, how it, the 3D will look like. Let's show you. Yeah, give me a minute. So this is, see guys, how it beautiful look. So even if you delete this, see, I need to delete this this room. What is that? So dining table in this. So I just click on a delete. So that was deleted here. Okay, let's see. See that was deleted in this. Let's just go to the level 1. So just see it. So my dining table was deleted. Okay, wherever you want, you can work wherever you want. Okay, if suppose you want to see the solar analysis, how the solar analysis, and even though we can do the solar analysis also, but is we have some type of things in a BIM. BIM is a so 2D, 3D, 4D, 5D, 6D, 7D we have. So some of the Ds will represent to the some solar analysis estimation. These all things we have. So that's right now we can't cover those things. But here is a sun. If suppose 130, if the sun will be at 130, so how the wind means that shadow will look like. So if you are in a inside of that, how much lighting you have in that 130, based upon that, if suppose I have a few lighting in my first floor, I don't need to place a, if I place a I don't need to place a light and these things. Okay, based upon that also you make it will connect to the green buildings. Okay, so what is the green buildings? By using the natural sources, how we can decide how we can give optimization in our all the construction. So this is a 3D view. Okay, you can see it, and this is a land actually. So and after that you can see, and here is a one person is sitting here, and this is a dining table, and here is a laundry, and here is a sofa set, and this is a some podium, and here is observation deck, and these are the, and this is some areas, walking area, and these things. Okay, this is how it will show you. And come to the elevation. So no need to work on elevation once and the section once and 2D plan once like that. So once you draw in a 2D model, and like in one model, it will give you all the details. So if you draw in a 2D, so you need to give in some information. See this. This is an east facing direction. Okay, so once you click on here and just go for the shadow lines, you can get a, see this, how the color windows color and these things. Okay, how the car will look like. And west facing also, if you wanted to see the west facing, and again you no need to draw it while we are drawing a 3D model. So these all the views will be generated automatically. Okay, and after that section, if you wanted to see the section, building section, so just click on here. So you can see it, which section it is, building section. So let me draw one section here. So exactly in this level 1, I need to see one section. So let me show you that. I need to see exactly this. What is that? Yeah, these are dining tables. Okay, so for that, just go to here. Here we have a section. Take the section here. Yeah, just click on exactly here. Just draw like this. I make a section actually. So after that, I need to see in this direction. While we are in BPD, we studied, if you stand in this direction, if you see in the straight, what are the things you can visible? So that is the main thing. And if you just turn on it, and I just double click on here. So once I double click, it will open that section. See this, whatever the mention, I can see my dining. Okay, so shadow, make it as a shadow. You can see my dining, whatever the glasses I can visible, those can be visible here. Okay, so that is how we can generate the section. And here is the section view, detail view, and render view. So how we can give it to the client? So if I just give it to the client in this range, see this, if I give it to the client in this picture, so you can definitely mesmerize. Okay, So based upon that also you can somewhat see. If I give it to the kitchen in this, so I said to the client, sir, once you follow our drawings and everything, you will get a building like this. So then he can surprise it. Okay. So without any physical appliances, after the before the construction, if you see this model, how you can felt it. So that is the main thing. And also Etabs also give you the scheduling, planting schedule. If you wanted to particularly, what are the plants I made in this drawing, those all the plants you will count it. Okay. So honey locust, it's the 8 number of plant I use in this project, and all this whatever the material you use and how many columns you will use, all you will get at the schedules. And after that you can generate the drawings also. Once you click on the title sheet, you can generate, this is a drawing. You just simply you will change it to the Autodesk into the your company brand, then you can publish to your client. So this is how your project will look like. This is a 3D model, and here is a kitchen, and here is a hall, and here is elevation, and this is an entire room, and these are the some of the information. So if you give it like this, so you can felt you can feel that so this is the best consultancy company which is giving. Okay, so like that they will felt. Okay, if you wanted to give it the site plan, so you can see here. So yeah, see this. This is a site plan, entire site plan. Okay, and once you go to the scheduling rendering, okay, I hope you've seen the rendering, right? So this is how we can give it. So once you go to the third one, last one, so elevation, the staircases. If you wanted to show the staircases drawings, so this is how we can see the show the staircases drawings to the client. So this is a plan view, this is a section view. If you go to the section view, here is a staircases, how many threads you will get, how many widths rises you will get, those all the information we will give here. Okay, so this is what architecture will do. So if you just click on a 3D, so entire 3D will be come. Okay, if you just delete this roof floor, just delete all this, and you can hide it also. So whatever the things you can do it in the Revit. So SketchUp is not like this. Okay, SketchUp is whatever the information you are giving in a Revit, that information Revit will store all the information that will give you by the scheduling. So see this, I just delete the roof actually. So like that. Okay, so I hope this is how the Revit actually, but we have a lot of software to explain what are the softwares. RCDC we have, and the SAFE we have, and also SketchUp we have, 3ds Max we have. So these are softwares, but I'm not telling you learn all the softwares, but whatever the softwares you want to learn it, so learn those only. Once you learn those, definitely those will help you to get the job. Once you join the job, then you can learn more things from that company. Okay, initially try to learn software from anywhere, then after that you can grow yourself and you can get the technical knowledge. Then after you will go to the job, at least get a job by using this technical knowledge and the software knowledge. Once you join the job, you can improve yourself by discussing and doing some projects, then only you will get the some highest salaries. Okay, this is what I wanted to tell you. I hope I cover everything is clearly.